Hello everyone, my name is Santosh Kumar. Today I am presenting a capstone project on integrated retail analytics for store optimization and demand forecasting. So this project builds an end-to-end retail analytics pipeline on the Walmart store sales dataset that covering data understanding and pre-processing, feature engineering, exploratory data analysis, anomaly detection, and row-level time-based and time series decomposition, trend and seasonality, store segmentation, unsupervised learning, and market-based department association analysis, demand forecasting, multiple machine learning model compared on that, external factor impact analysis CPI, unemployment and fuel prices, strategic recommendation, evolution challenges and learnings. So this is the GitHub repository. This is the GitHub link of my drive, and also I have firstly submitting my docx file, Google Doc Word file. So firstly we have installed the setup install by import mlx10 and pip install -q mlx10. We have printed the setup complete. After running this command, it is showing the setup complete. I am running there once. This is time taking process. Okay, this is showing setup complete. After that we have import OS and libraries. Import OS, import warnings and import numpy as np, import pandas as pd, import matplotlib.pyplot as plt, import seaborn as sns. From sklearn ensemble import isolation, and we have import many libraries, and this is showing the version of this code: numpy 2.02, pandas 2.2.2, and sklearn 1.6.1, stat models and matplotlib mlx10. This is the version also showing. So we have data loading. After that we have this project have 3 CSV files, that is Walmart retail sales dataset, sales data set CSV, feature data set CSV, and store data set CSV. So we have uploaded by data folder in the left panel. This is here files, and after that we have import system globe, and we have run the code, and this is the code for that to uploading in directories sales. After running this code, we have got it sales 4,21,570 with 5 columns. Features 8,190 with 12 columns, and stores have 45,3. After that we have data understanding. Quick structural check: data types, data range, missing values, and target distribution. So this is the code for that. For DF in sales, features print sales depth range, unique stores, missing values. So after running this code, we have got at the sales date range. So this is the date range 5 to 2010 to 26 to 10 2012. So unique stores are 45, unique depths are 81, and missing value in feature dataset: store have 0, date have 0, temperature has 0, and fuel price also 0. Markdown has 4,158, and so on. Negative weekly sales rows, we have count. This is the weekly sales. This is mean, standard, mean, minimum, and 25%, 50%, 75% maximum. And data type is float 64. Data cleaning and merging. After that we have clean the data, merge the sales plus features dot and stores.csv. So we have 3 files. We have merge this into one master table. Mark down columns, negative values clipped. So CPI, unemployment interpreted per store. These move slowly, predictably on over time. So weekly sales, negative value, net returns excluding sales, clip to 0. Modeling the raw values in capital weekly sales row for annually audit purposes. So we have write the code for that: DF sales merge and this. So after we run the code, merge and clean shape are 4,21,570 with 17 rows. We have merged the 3 CSV files. Remaining NAN with series and data type. Data type are integer 64. And this is the value for that after running the code. It have store, department, date, weekly sales, each holiday, temperature, fuel price, markdown 1, markdown 2, markdown 3, 4, 5, CPI, unemployment, and type, size, weekly sales row, so on. And official Walmart. After that we have made the feature engineering for that. So new features created. Calendar features: year, month, week of year, quarter. So name, US holiday, flex, Super Bowl, Labor Day, etc. Total markdown, size, category, sales per square feet. SQF to show leg and rolling features for stores. We have made the feature engineering for this code is run. So feature engineered shape have 4,21,570 with 33 rows. So this is the value got it. After that we have made the EDA exploited data analysis. For that we have made this code and run the code for that and plot a graph. Total weekly sales across all stores. So this is by date wise. So this is the total weekly sales by 1 to 5, 5 to 9, 9 to 2010 to 1 January 2011. So this is total weekly sales. Here we have got the 8 sales value, 8 plus sales values in January 2011. So this is the value for that. After that we have made the average weekly sales holiday versus non-holiday. So we have got these two values. Is holiday false or true? Either true, it have 16,000 weekly sales, and if false, this is also sometime 15 plus sales, 15,000 plus sales. So non-holiday versus non-holiday sales this is showing. So this is the total value 15,901.64 and true have 17,000.36 values. So we have plot a figure weekly sales distribution by store type. So this is the A type, B type and C type. This is the weekly sales. And we have store size versus average weekly sales. We have made a dot graph chart. Dot chart for that. So weekly sales and so type A have green values and B have red orange values and C have blue values. After that we have made a correlation sales versus external economic factors. So this is the diagonal. Weekly sales, temperature, fuel price, CPI, unemployment. With weekly sales, temperature, fuel price, CPI, etc. After that we have average weekly sales by month. So this is showing in 12 months, 12 and 11 months more sales, November, December. So EDA takeaway, sales spike sharply around the Thanksgiving Christmas holiday weeks, which were at the tallest peaks in the trend chart. And store type A store's largest format have both and highest median sales in the widest spread. So this is got the value we have. And anomaly detection isolation forest and with Z score. So this is the value for that. Time series decomposition, trend, seasonality, and so this is the value for that. Three graphs: observation, trend, and residual. Interpretation for that. Sorry. Store segmentation, unsupervised clustering. We have made the code and run the code. We have got the chart of PC2 and PC1 values. So average weekly sales by store segment. So this is the segment type by 1 2 3 4, 0 to 4, and average weekly sales 25,000 in segment 2, 25,000 plus, and this the value after market basket analysis department association. So individual customer transaction are not available in this dataset. So we info department level product association for every store week basket. So this is the value for that. And top department cross sell association by lip. So demand forecasting for that. So this is the chart for demand forecasting. So actual have this value is blue wise, and red have this values. So this is the graph for that. So this is the real analysis for that. And forecasting model comparison, RMSE. So lower is better. This is linear regression, random forest, and gradient boosting. Top feature importance will random forest. Impact of external factors, CPI, etc. So this is the chart for the standard effect of external factors in weekly sales. So strategic recommendation for that: inventory management, marketing and promotion, store optimization, forecasting operation. So evaluation, challenges and learning. We have faced many challenges on that. Standard map is unstable on data because many store department weekly sales values are close to zero. So no real per customer transaction log exists, and markdown columns are heavily missing. So optimization applied. We have key learning for that and future improvement on. This is the real transaction level data would allow a true market basket analysis. Currently departmental level, not SKU customer level. Store department level personalized and longer history would allow more robust long term. And conclusion for that: so compatible detailed analytics pipeline for raw data cleaning through anomaly detection and segmentation, market basket influence, demand forecasting and external factor analysis. So inventory, marketing and store optimization and recommendation. So thanks for watching.